Welcome to the Inspiring Tech Leaders podcast with me, Dave Roberts. This is the podcast that talks with tech leaders from across the industry, exploring their insights, sharing their experiences, and offering valuable advice to technology professionals. The podcast also explores technology innovations and the evolving tech landscape, providing listeners with actionable guidance and inspiration. It's been a few weeks since our last episode, and that's partly because I've been travelling. I've recently returned from a fantastic business trip to India, followed by a much-needed family holiday to recharge and reflect. But what a week to be away. Big story last week was the major AWS outage that disrupted businesses and services across multiple regions. From e-commerce platforms to enterprise systems, the ripple effect was huge, and it also raised some serious questions about cloud resilience, disaster recovery, and how dependent we've all become on a few key players in the infrastructure space. In today's episode, I will look at what happened, how AWS responded, and what this means for business leaders planning their own business continuity and multi-cloud strategies. The disruption began in AWS's US East 1 region in Virginia, which is one of its oldest and most heavily used data center hubs. At the heart of the failure was DynamoDB, AWS's managed NoSQL database service heavily used by many customers. A deployment or update triggered a bug in an automated DNS management systems used by DynamoDB, resulting in an empty DNS record in the US East 1 region. That record should have healed itself via automation, but it didn't, and it cascaded into failures. Because many clients and services had to resolve domain names via DNS to reach DynamoDB's API endpoints, the failure prevented connectivity. In short, you couldn't find the service. Once DynamoDB became unavailable, other dependent AWS services, traffic routing, and applications that rely on it also started failing. A simple analogy is to imagine a central directory mapping names to addresses. One of those entries became blank, and the automated system that should repair it is broken, so the services referencing it can't find their address and essentially go dark. The outage didn't stay local though, it rippled outwards. Over 2,000 services using AWS were affected globally, including major consumer apps and critical infrastructure. Apps like Signal, Snapchat, Duolingo, Roblox, Zoom, WhatsApp, and more experienced outages or degraded performance. In the smart home IoT world, some users lost control of their devices. So for example, I wasn't able to view my own Ring cameras back home when I was on holiday. Banks, financial platforms, and government services also felt the pain. In the UK, the HMRC portal became inaccessible to many users. Many services saw a backlog of pending requests once systems came back online, leading to delays and intermediate errors even after restoration. AWS acknowledged that while the root fault was resolved, residual issues lingered. The outage lasted several hours depending on the region and where you are in the world, with parts of the recovery stretching into the day after. Because modern applications are deeply layered and independent, a failure in a core service like DynamoDB rapidly propagates upward. Some sectors were disproportionately impacted. Social messaging, gaming, and streaming services have much of their backends rely on AWS. Any interruption reduces user trust, increases churn, and damages brand reputation. When banking apps, payment gateways, or transaction logs are momentarily halted, the risk is direct, including failed payments, delayed settlements, regulatory exposure, and customer complaints. Services like tax portals, benefit systems, or public infrastructure tools that rely on cloud services were also disrupted. Even devices that seemingly just work usually depend on cloud connectivity. Many vendors are now rethinking fallback modes, including local Bluetooth control to mitigate this risk. If your internal tooling like ERPs or CRM systems sit on AWS, downtime means downtime across the board with productivity hits, data gaps, and operational disruption. While outages like this are technically cloud issues, their economic implications are non-trivial. Many e-commerce platforms or subscription services lost sales or had failed checkouts during the outage window. Every minute offline for a high-volume platform is lost revenue. Even after restoration, trust is eroded. Customers may migrate or demand SLAs or reduce dependency on fragile systems. The brand impact can outweigh the direct loss. This outage is a stark reminder that the relatively small number of cloud providers host a huge share of global digital infrastructure. AWS alone holds circa 30% market share in cloud services. Concentration means a failure in one major vendor becomes a systemic shock, with a too big to fail notion applying to these cloud providers. Digital platforms drive commerce, logistics, fintech, media, and so forth. When they go offline, ripple effects appear in consumer spending, marketing, ad delivery, logistics, payments, and more. Such events increase pressure on regulators, especially in sectors like finance, healthcare, and government, to enforce greater resilience, redundancy, data sovereignty, and stricter SLAs. Investors may demand more risk management, cloud diversity, or contingency planning. This may accelerate adoption of multi-cloud or hybrid cloud strategies, edge computing, and the notion of graceful degradation, where systems can run in a limited mode if core services fail. While a single outage may not derail GDP, for digital economies, cumulative outages and the price of reliance is rising. From a leadership, architecture, and risk perspective, what should organizations and stakeholders take away? Well, don't treat cloud as a fire and forget black box. Plan for failure. Use multi-region deployments, failover paths, redundancy, and fallback modes. Where possible, decouple dependencies. We should avoid putting all our eggs in one basket. Use a mix of providers such as AWS, Azure, Google, and on-prem to reduce single vendor risk. However, multi-cloud does add complexity and cost, and these trade-offs must be carefully managed. Simulate failures to understand propagation. Ensure you have runbooks and manual override paths for automation failures. During outages, real-time communication helps maintain trust. Post-mortem transparency is important to determine what happened, root causes, and mitigation plans. In regulated sectors such as finance, health, and government, regulators may impose higher resilience or redundancy demands. Enterprises may demand stricter SLA guarantees or risk diversifying away from single providers. Shifting more compute and data closer to users with edge computing can reduce dependency on centralized data centers. Decentralized architectures might also help spread the risk. It will be interesting to see if AWS or other cloud vendors change their DNS, automation, or fail-safe designs, whether customers begin seriously shifting to multi-cloud or hybrid clouds. We might see regulators in the EU, US, or other markets propose stricter cloud resilience requirements. We will need to monitor the frequency of similar outages in other cloud providers and see if this will be a one-off or part of a pattern going forward. And could this be a target for cyber warfare too? Well, that's all for today. Thanks for tuning into the Inspiring Tech Leaders podcast. If you've enjoyed this episode, don't forget to subscribe, leave a review, and share it with your network. You can find more insights, show notes, and resources at www.inspiringtechleaders.com. Head over to our social media channels. You can find Inspiring Tech Leaders on X, Instagram, Inspo, and TikTok. Let me know what you think of the recent AWS outage and if it impacted you. Thanks for listening, and until next time, stay curious, stay connected, and keep pushing the boundaries of what's possible in tech.